Okay, let's keep going with these sign chart ones. Hopefully we can finish these 4 in this video, and then we'll be done for the day. Alright, again, first thing you need to do is get it all on one side, so I'm going to subtract that over. X cubed plus x squared minus the 12x. Keep the symbol the same, right? But when you move it over, it's gone, so it's 0 on the left, or on the right. Then we could factor an x out of everything. And then we can factor that a little bit farther. I think that's going to be a plus 4 minus 3, I think. Plus 4 minus 3. Check it. X squared minus 3 plus 4. Yep, plus 1. Yep, that looks good. Alright, so then we find the critical points. Got 0 from that factor. Got negative 4. And got 3. So the first thing is get it all on one side so that we have a 0 on the other. Factor it completely. Take all those factors and find the important values. I'm going to go ahead and just take all this stuff, and I'm going to do my little sign chart down here just so I have room enough for it. So I got negative 4, 0, 3. Doesn't have to be to scale. It doesn't matter. All of those were x-intercepts, so all of those produce out zeros. And then, since we have the 3 critical points, I'm going to have to test the 4 created subintervals in between them. So let's go for it. Test point for this interval, anything bigger than 3, like 4 would work, or 17 would work. Any number, just pick something that's easy. I'm going to go with 4. If I plug in 4, remember, you could plug it in here, but then you have to think about in your head, 4 cubed plus 4 squared minus 12 times 4. Like, that actually takes a little bit more math. It's easier to just plug it into the factored version and then just think about the pluses and the minuses. So let's plug in to this factored version. Again, plugging in 4 for this interval. First chunk would be positive. 4 plus 4, that's positive. 4 minus 3, that's also positive. Right? And if all the chunks are positive, that means overall positive. A good test point for this interval would be 1. First term would be positive. 1 plus 4 would be positive. And now look, 1 minus 3 would be negative. So you've got 2 positives and a negative. So then overall, that term is going to end up being negative. Alright, and then we need another test point for this interval. Negative 2 works. If I plug in negative 2, now that leftmost chunk is negative. If I plug in negative 2 plus 4, that's still positive. Then if I test negative 2 with that rightmost chunk, negative 2 minus 3, so that would be negative 5, which is negative. Alright, so I've got 2 negatives, which would cancel, and then overall, it's going to end up being positive. If you have an even number of negatives, they're going to cancel out. So when you have an odd number of negatives, that's when the overall result is going to be negative. One more interval, and then we can get our answers. So let's test something like negative 5 or negative 20. Either one would be fine. I'm just going to use negative 5. First chunk would be negative. Second chunk, negative 5 plus 4. That would be negative. And then, let's see, negative 5 minus 3. Ooh, that's negative. Right? So I've got 3 negatives. 2 of them would cancel, but that means 1 of them would be left over. And yes, there's kind of a shortcut. If you think about what you know about multiplicities and whether it's going to cross or bounce, right? All of these factors had multiplicities of 1. So if I was thinking about the graph of this polynomial, it would cross, and it would cross, and it would cross, right? It would cross the x-axis. So that means, hey, at this x-intercept, if I knew it was positive, I knew it was going to cross the x-axis, so this would have had to be negative, right? Because if it crosses from being positive above to being below and negative, right, that should reinforce the whole idea with multiplicity. This sign chart and what we know about multiplicity and crossing or bouncing should all fit together. And look, right, it was this x-intercept, 3, that was the chunk that ended up changing. That was plus, 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 and then when I moved from this interval to the one to the left of it, it was that plus that changed to a minus because it was this factor, right? We were dealing with the 3 intercept, which was this factor, and since it had an odd multiplicity, that was supposed to change, which changes overall. And then here around 0, right, that's supposed to change, which changes it overall. And then around 4, It's supposed to change. So there's some shortcuts. The better you are with your polynomials and you knowing about the multiplicities, the faster you'll get. But at the end, what we're going to want are for all of these values that produce out negatives or that produce out zeros, right? Here we do want to include the zeros because you have the or equal to bar. So let's check it out. I want the negatives. I'm going to want the 0. I don't want the positives. I want the 0. I want all the negatives. I want the 0. Don't want all that stuff. You don't need to do the pluses and the checks or the x's, right? If you can just visually see, hey, like this is negative and 0, so I want it. Don't want all this stuff and that endpoint, right? You don't need to do this, and in fact, I'm probably going to stop doing it on the next one. But the sign chart is how you get the answer. It's not the answer, but it's how you get it. So negative infinity to negative 4, and I do want to include that negative 4 because of the or equal to bar. Okay, and then the next interval is going to be here, 0 to 3, include the 0, and then include the 3. Right, so here's your answer for that second example. Moving on, let's look at the next one. Oh my gosh, it's already factored for us. How incredibly lovely. So let's go ahead and just find the critical points. I got negative 3 over 2. Remember, you would just set this equal to 0, solve it for x. Here, if you set this equal to 0, you're going to end up solving, add the x over. So you have still the 2 factors. That means you're going to have the 2 special values, and then let's test them by testing them with the sign chart. Both of those are x-intercepts, so they're zeros. At the end, we're going to want the outputs that are negative, right? So let's go test these intervals. If I plugged in something like 5, let's see, 2 times 5 would be 10. 10 plus 3 would be 13. 13 squared would be positive. And then let's see, 4 minus 5 would be negative 1. Negative 1 cubed would be negative. So overall, that interval is going to end up producing you a negative output. Now, I kind of like to look for shortcuts too, right? If you're thinking about this left chunk, right, this left piece inside the parentheses, it gets squared. If I have a positive number and then it gets squared, it ends up being positive. If I have a negative number and it gets squared, it's still going to give you positive, right? And even if that was to the 12th power, it would still be positive. Anytime you see an even exponent, you know that chunk is going to always end up giving you a plus, right? Because anything to an even power is positive. So what I would actually do is save a little bit of time. As soon as I see something with a multiplicity of 2 or 4 or any other even number, I would kind of just cheat. And then I would say, hey, this left chunk I know is always going to be positive. And then you don't really have to bother testing it. You can just test the remaining chunks. Like here, if I plugged in 5, or 4 minus 5 was negative 1. Negative 1 cubed is negative. Right, let's do the next one. Like plug in 0. 4 minus 0 would be 4. 4 cubed would be positive. So that means overall you'd be positive. And then if I was testing this last interval, a number like negative 5 would work. 4 minus negative 5, careful when you minus negative, that would be 9. 9 cubed would be positive. So then overall that would be positive. Let's think about kind of some multiplicity, right? This factor had the intercept at 4. This factor had an odd multiplicity, and so that means the graph would cross the x-axis, and look at that, it changed overall, right? Just like we thought it should. This factor gives you this negative 3/2 as the x-intercept, but that factor had an even multiplicity. So if I was thinking about the graph of this polynomial, it would not cross, it would just touch, or it would bounce on the x-axis. So it's positive on the right, positive on the left, right? No change. It doesn't cross over the x-axis. So that kind of reinforces our idea of multiplicity. Anyways, we want, at the end, all of the intervals that produce out negatives. I don't want the zeros. I don't want the pluses. I'm just going to want the intervals that produce out negatives. So just going to be from 4 and then to the right, exclusive on both. Okay. On the next page, now we have a rational. That's okay. If you've got a fraction, you've got a top and a bottom. You just factor the top and factor the bottom. So the fractions seem like they may be a little bit harder, but it's the same idea. All right, let's factor it. So I've got x minus 5, x minus 4. Check it, but that's how it factors. Then on the bottom, you're going to have plus 3, minus 3. Doesn't matter. You could put those in different orders, but we're going to be looking for where this is greater than or equal to 0. So I'm going to want the positives at the end, or I'm going to want the zeros at the end. Let's go list out all those special values. I'm going to have 5, 4, 3, negative 3. Make sure you get them in the correct order. Doesn't have to be to scale, right? Doesn't matter. Now here I'm going to have some differences. The 5 and the 4, those are factors coming from the numerator, which means they're x-intercepts, right? Those are zeros. But these two things are vertical asymptotes. Those aren't zeros. Those are undefined, right? So I like knowing whether this special value is a 0 coming from the top, or whether it's an undefined coming from the bottom, right? Intercepts or asymptotes. Now let's test the intervals. Let's figure out at the end which ones give us positives, which ones give us zeros. All right, so plug in 6 to test this interval. Let's see. 6 minus 5 would be plus. 6 minus 4 would be plus. 6 plus 3 would be a positive. 6 minus 3 would be a positive. It doesn't always start with all the chunks being positive, but a lot of the time it will. And then gradually, as you move yourself across this number line, one of them is going to change at a time. But again, I would just actually take the time to do it. It's not that hard. If you need to, you can kind of simplify this down. You have a positive on the top. You have a positive on the bottom. Then you can think, if I have a positive divided by a positive, it would be a positive overall. If you can just jump straight from this to this, that's fine. But if you need to simplify and figure out, hey, what is the top? Then what's the bottom? Then do overall. That's fine. But this is the individual pieces all being plugged in, and then that's the overall. Okay, let's test something like 4.5. 4.5 minus 5 would be negative. 4.5 minus 4 would be positive. 4.5 plus 3 would be positive. 4.5 minus 3 would be positive. So it's just the one chunk that changed, and it was the chunk that was around that factor, or that x-intercept. Right? But overall, that one would end up being negative. Okay, next let's test 3.5. We're going to have a negative, negative on the top, positive, positive on the bottom, which means overall positive. Test something like 0 for this next interval. You're going to have negative, negative on the top, positive, negative on the bottom. You have 3 negatives, so that means overall it'll be negative. And then all the way over here on the left, test something like negative 8. It's going to be negative, negative on the top, negative, negative on the bottom. Ooh, but since there's 4 negatives, it all cancel. Right? And you can kind of get a lot faster at this. You don't necessarily need to always show all the work, right? Once you kind of pick up and you can do it faster, feel free to just do as much work as you need. But the sign chart is how you get the answers. But remember, I need to now collect all the intervals that are positives or zeros. So let's answer this, right? This interval I'm going to want. So negative infinity to negative 3. Would I want to include the negative 3? Does negative 3 produce out a positive, or does negative 3 produce out a 0? No, negative 3 doesn't even produce out anything. It's an asymptote, right? It's undefined. So you always put your parentheses on the asymptotes. That's why I like to know the difference between the undefines and the zeros. You would never, ever put a bracket on an undefined. Okay, next interval, right? That's all negative, so I don't want it. So the next interval is going to be between 3 and 4. Parenthesis on the 3, because it's undefined, do not want to include. The 4 produces out a 0, and I do want to include them. So a bracket on the 4, don't want anything here, but I'm going to want from 5 and onwards, bracket on the 5. Ooh, come on. All right, one more example.